8.8 is on quadratic inequalities. You'll do a lot more of this, and you'll go beyond quadratics in pre-calculus. In this Math 80 course, we're going to focus on just the quadratic type. So just to kind of make everything come together and see how everything's interconnected, I have the x-intercept, y-intercept, and vertex calculated here. Great practice as well just to do those, and allowed me to graph my parabola. But now I'm looking really for this 8.8 lesson at inequalities. So basically, I'm looking for when would, for example, the y be greater than 0 means the y value here is above 0, so above the x-axis. It's graphed in green. So the part that equals 0 are the intercepts I have in pink, and if it's less than 0 for the y, it's below the x-axis, and I have that in orange. And the reason I'm doing this is just to kind of put the visual to the math. So the method for solving these is that we want to know where is it at 0, because then we can determine where is it going to go above and where is it below would happen between those values. So when we factor and we find out the x-intercepts, we call those critical points, and we're going to be dealing with nice critical points on these problems. We're not going to have that many like quadratic formula ones or anything, nice factorable ones. So we want to know so those are where it's 0, so I marked 0 next to those two places here. I want to know, is it positive or negative between these? So in other words, is the parabola opening up like this, so between them it's going to be negative, or is the parabola opening downward like this? This is again if I didn't have the graph, how you do it algebraically. So, or is it going down like this, and then where it's negative would be on the other sides, on the outsides. And so this sign analysis is really helpful for being able to graph when it's not an easy graph later on as well. So when you do things that are not just quadratics. So we plug in any value to the left of our 0 to our intercept, value in between, and a value beyond. And we see if we get a positive or negative. So I did the test point of -4, and -4 plus 3 is negative. I really don't care what the value is. All I care about is the sign, because all I want to know is, are we greater than 0 or less than 0? And so we're positive here, and then we're 0 right here. And then in this region, I tested a point. I tested 0 because it seemed easiest to work with. Again, that's positive. 0 minus 1 is negative. Positive times negative is negative. So this is called sign analysis. We're just looking at the signs. So everything in here would be negative. Then I get back to my x-intercept. I get back to my 0. And then I test something on the other side. I tested 2 and got that it would be a positive. And so when we look at the graph, you can see that on the left side, when it was less than -3, I did have positives. It was above 0. These were positive y values. And over here, when it was more than 1, I had positives. Between -3 and 1 exclusive, I ended up having negatives. You can see all of that region is having a y that's negative. And right at -3 and 1, it is exactly 0. So the directions are right there. You can pause it and write it down. I can zoom out a little bit so you can see the example more completely. So it says using that sign analysis above, when is the function 0? We determined that was at -3 and 1. Those are your x-intercepts. They are 2 distinct points. They're not arranged, so we're using the set notation, the braces here. When is it negative? Meaning when is it less than 0? It was between -3 and 1. You can see it was negative in this region, so from -3 to 1 exclusive, so parentheses. Where is it positive? This region, so -infinity to -3. In addition, so united with 1 to infinity, again exclusive. There's the interval, there's the inequality notation. Interval notation, inequality notation. Lastly, when is it greater than or equal to 0? So now we can include when it is exactly 0. So we can include those points. That makes it have a bracket then. Just wanted to be clear on interval notation and practice that a little bit more, and practice inequality notation a little bit more too. So what if I actually show you the function instead of just say f of x? So here's our function. It's less than 0. It's already set to 0. If this had been some other number, we would have needed to adjust it, because we can only figure out if it's more than or less than or equal to 0 with our method for factoring. It has to be 0. So finding the zeros and then doing our sign analysis. Some number on the left, some number in between, some number on the right as test points. So I picked -4, then I picked 1, and then I picked 3 for my test points. I plugged it into the factored form. You could also plug it into the standard form. I just find it more cumbersome that way. And so I wanted to know, where is it less than 0, right? Where is it less than 0, meaning where is it negative? And it was negative between -3 and 2. And I just wanted it to be strictly less than 0, so I'm not going to include the zeros. So again, open dots and the use of parentheses. I graphed it here just so you could see how it works when you graph it. It's less than 0, meaning it's below the x-axis. The y's are negative. See, all the y values are negative in this region. A couple more. I'm not going to go through them all in their entirety, but again, set it equal to 0. So that you can do your factoring and find your zeros. This problem asked, where is it greater than 0? And so it's asking, where is it positive this time? So it's these regions. This was to practice the disjoint union situation as well. And your critical points can be both positive, both negative, one of each. They can even be fractions. Here's another one where it's a difference of squares. So some practice with factoring going on here. This is greater than or equal to 0. So that means 0 or positive. So it could be these. So I did close dots, or positive. So in between there was where it was positive. When I did my sign analysis, I tested the point 0 for my x. And if I graphed it, you can see, where is it greater than or equal to 0 would be from -3 all the way to 3. Inclusive. Number 8, get it equal to 0. Factor, this had an a that was not 1, so a times c, put your b, figure out what works, do your grouping, then get your critical points. Once you have your critical points, test points on either side of it and in between. So let's test, for example, -3, test here maybe 0, test here like 1. Do nice values, easy values for you to work with. So lastly, what if I gave you this function here and we found the zeros, the 0 being 5. It was a perfect square. So then I only have 2 spots to check, the left and the right of it. That also creates a potential for some special cases. Well, there's only one 0, we can see in B. It could be, when is it less than 0? Well, this parabola was never less than 0. It was either 0 or positive, so no solution. And you can see it here, it never went below the x-axis. If it said less than or equal to 0, well, I can include the 5 from the 0, but there's nothing else. This would have also been true if this just had equal 0. So this is not equal 0 as well as less than or equal to 0. It would be the same thing for this particular problem. For C, where is the function greater than 0? So where is it positive? Not 0, but greater than 0, so positive. Here, not right there, and then here again. So you have to exclude this point, so it becomes disjoint. Shows a little gap at 5 because of the use of parentheses, and these two both being 5. So that tells us there's a gap right at 5. Where is it greater than or equal to 5? Sorry, greater than or equal to 0? Well, it was equal to 0 here, greater than here, and here, so it ends up being everything. So that's one of those special cases again. No solution, infinitely many. Here there's just one thing. Here there's a gap. I'm not going to spend a lot of time on this, but if you try this with your graphing calculator, you can also do this by not getting it equal to 0, but seeing where is this one less than or meaning lower than or equal to this. Where they're equal to is basically the it's pretty important because then it's going to be less than in some parts and greater than. So here you can see that the solid line is above the dashed, then it goes below, and then it goes above it again. And where they were equal is where it changed from going above it to being below it, then being above it again. That's why that equal part is pretty important. It's pretty faint here, but basically this is just showing you that you can do it by the factoring method, get it equal to 0, factor, find your critical values, do your sign analysis. It was positive, then it was 0, then it was negative, then it was 0, then it was positive. And so again, the question here was when is it less than or equal to 0? So less than or equal to means you're going to include the zeros. The less than is where it's negative. And so there's your answer. And you can see in the graph that where it was less than was or equal to was where it intersected all the way through here and then all the way to where it intercepts again, because that's where it's equal, and that's under, meaning less than. If you have this equation, you can also get it by looking at the graph with the calculator. I just want to show you that it does match up graphically. All right, so that is it for 8.8 on quadratic inequalities. Here are the main directions. The important part is critical points, testing the signs of points on either side and in between any zeros that you have. And if it's less than 0, you're looking for where it's negative. If it's greater than 0, you're looking for where it's positive.